One of the techniques that I like to use whenever designing castings and forgings, especially around known geometry like we have here, is to insert a component into the assembly and then design around that. And so that's the technique that I'm going to employ here as we built our drafted geometry, our taped geometry around this machined design. Let's take a look at the components before I do that. We've got a lower main bearing and then an upper main bearing, and then we've got a pin. This pin is used for location. It's used for keeping anything from slipping while the assembly is in being used. And so something like a pin is so readily available off the shelf. We really don't want to design this feature into our component, into our casting design for this bearing. And so we may just want to come in here and hide that component just to get it out of the way. And we can see that everything's going to be a subtractive feature, and that'll make a little more sense after we get the actual geometry created for our bearing. I do want to create this as one part because it's very common that we'll want this hole to be concentric between both components. And so we'll want to come in here and create one bearing casting that will be split later on into two halves. And so that way we can keep that hole in our design. And so with that in mind, let's go ahead and get started by inserting a new component. We can use the insert menu, or we can also find this from the assembly toolbar. Under component, we have the option to add a new part. When we do that, we're going to be asked, if we notice down at our status bar on the bottom left hand corner, we're going to be asked to select a face or a plane in which to position the new part. Whichever face that we select will be the front plane for the new component. Now, seeing as this is situated ideally for what we want to create, I'm going to use the front plane of this assembly to define the front plane of the new component. The default settings within SOLIDWORKS is that all the other components are going to become transparent except for the one component that we are editing currently, which is this new component here. It's also by default that the new component that we added is considered a virtual component, and it uses the default template that has been established in our options. Let's pause for just a moment and take a look at those options. SOLIDWORKS options can be accessed by going to the Tools menu, to the very bottom of the Options, or choosing the Options icon from the top toolbar. Once we're inside the options, there's a few areas that I want to highlight for you. First of which is under Display Selection. This is where we specify how the transparency is going to be set for any new components that we create in the context of an assembly. And you can see the default here is to force assembly transparency. The other two options available are opaque assembly or maintain assembly transparency. Maintain assembly transparency will leave transparent components as transparent and opaque components as opaque, as those are being set prior to using the insert part option. Next will be under assemblies. As we look under assemblies, we can see that there's an option to save new components to external files. This would be the traditional way we've created files within SOLIDWORKS, where each file is its own data set saved within PDM or on a network location, hard drive, wherever you may be locating your files. With this option not set, as it is here by default, it's going to create this new component as an internal component, meaning that it only exists in this assembly. We're going to remedy that a little bit later, but I wanted to point out this option to you so that way as you're working in context of an assembly, you'll understand how and why that it puts these brackets and this caret as part of the name of the component. The last one I want to point out to you is default templates. Based off of what I have set, this is the template that was used to create the new component that I inserted into my assembly. You should set these up as part of your default settings whenever first working with SOLIDWORKS. I'm going to say OK to dismiss the options dialog box. One of the things you should notice, and I'll leave the default transparency here, that'll just help us understand that we are working in the context of an assembly, and we're working on a component. And we know that the component's blue. Again, by default, the other parts are transparent. We also can take a look at the top bar here and see that we are looking at sketch 1 of part 2 main bearing in main bearing. Again, all that stuff's just to let us know that we're editing a component in the context of an assembly. So what it did for us is it started a new sketch on the front plane. And so we want to go ahead and move using Control 1. We'll look at the front plane and start to build our geometry. Front plane is going to act as a parting plane for us. And so all of our tapering and all of our draft is going to come from the front plane and outwards to the extremities of the parts. So for some of this, we're going to use the part geometry. Other parts we'll just sketch in. I like to start off with the main thing that's the most important about this bearing, and that is that we need a circle right here in the middle that we're going to specify our minor diameter on our material. Using the S key, I can quickly get to the circle tool, and I can either use the default circle or perimeter circle. Here I do want to use good design intent. I'm going to use that origin, and I'll just drag out here a little ways and select again with the left mouse button to place my circle. I'm going to use that S key again, and I'm going to go over to the Smart Dimension tool because I want to quickly define between that circle, and I'll use the geometry of this bearing and say I think I want it to have about 60 thousandths of material. Now you'll notice that the particular units I'm using right now are in inches. This assembly was built using metric dimensions. But while I'm inside this default part template that was used, I can see here from the lower right that my units is the IPS, inch, pounds, and seconds. I'm going to go ahead and add a few more dimensions in here before I exit the sketch and make a change to the units. If you happen to make a change to the units mid-sketch, it's just going to exit you out of the sketch, which you can re-enter using Edit Sketch in order to get back and do the work. So let's take a look. I use the Escape key to get out of that command, and now I can start to select either individual edges or I could choose faces. But what I want to do is I want to offset this geometry to get me some more material than is needed for this machined part, because typically we need to allow for imperfections as part of the casting, forging, or whatever molding process that we're doing here. So with those three edges selected, I'm going to choose to offset entities, and then we can set up our parameters. And so maybe in this case we want to come out that 0.06 in inches here, and I want to reverse that so that way I see the yellow preview updates where I can see that it's going outside. I need to at least have more material than what is for our machined part, because the machined itself is pretty is reduced to an amount that lets us minimize the amount of stock that might be needed. Green check mark there will accept the offset. And anytime that you do an offset off of geometry, it's going to be exact for that length of that edge. But what we can do is we can pick those up and drag them along here and let the inference lines snap those back up. Another thing that I like to do is I like to have lines of symmetry established using center lines. And so maybe I want to come in here and specify what our center line is going to be, and that might allow us, as we draw the rest of our geometry, get us to a point to where we're minimizing the clicks to get that geometry. And so I'm going to sketch this in. And we know that we're going to have to draft a lot of this geometry. We're going to have to add taper to it to get it in and out of a mold. And so what sometimes people will do is they will come in and they'll go ahead and draw in angles that might be needed to help out with. There's a little bit of an order of operation, and it's never the same for every piece of geometry. But I'll just say that whenever you're doing this, it's a lot of times better just to leave it as straight geometry and then come back later on and add your draft angle using the draft feature, which we're going to learn about a little bit later. Use my right mouse button and or S keys in order to get in and out of commands very quickly. And here I'll select a series of entities and then my center line, and this is going to allow me to use the mirror entities, and it won't ask for any other input. Tony Riggs does a video on symmetry and mirroring, and so if you're looking for more information or detail on that, be sure to look for his SOLIDWORKS Essentials, Symmetry, and Patterns. I need to check and make sure that everything lined up here over on this side, and it did. If it doesn't, we just drag the endpoint of that entity in order to get it exactly where we want it placed. Now, the reason why I did it this way rather than using the consistent offset is I wanted to control each face independently. I'm going to work all the way over here on this right hand side because I did create this geometry and then mirror it over to the other side. So let's go ahead and dimension that off. I want to add a minimal amount of information to the top of this, and so I'm going to come in with 30 thousandths inch face here, and then I also want to do very minimal amount here, so we'll do 30. But here on the bottom, I want to make sure that I get a really nice, clean, true face. And so for that, I'm going to make sure that I add 60 thousandths. And these are just nice, round, even numbers that I've used just as part of my own experience over the years that I like to have for these types of components. Down here, this is another situation where I need a minimal amount of material, and then on the bottom as well. It's up to your design intent, your liking. Some would argue that I need more material here on the bottom. Again, it's up to your discretion, design intent. And if you'll notice, I'm also not adding any fillets. I think all fillets and draft need to be added as a secondary operation. We've got our sketch where we want to. Now we're ready to make the extrude. I'm going to start off trying to use the extrude with draft option. So whenever I do that, the default nature, and I'll go ahead and rotate this around out of plane so we can see this. The default end condition is going to be a blind extrusion. And we could grab a hold of this gray handle out here and drag this along. We could use snapping to the scale increments, and we could get, somewhat close. And a lot of times whenever I'm designing something from scratch, I'll do that. I'll just drag it out a ways, and I'll see, does that get me close to a round number? Just growing up manufacturing and production, I like to use values that can be measured easily, even with a tape measure. And so I do tend to use round values, at least to the nearest fraction. But I look at this and I see I really want to drive this with a little more design intent than just out to a point. Maybe I want to make sure that I have a certain amount of material outside of this face that's out here. So instead of using blind, I want to use an offset from surface. So whenever I choose offset from surface, I can select the surface of our bearing housing. Hopefully you can see that they're highlighted in pink. And I want to offset that, the 30 thousandths inch that I'm using on others. But you'll notice the default is it's going to be 30 thousandths shy. So I can choose the reverse offset, and it's going to go beyond this face, the 30 thousandths that I'm looking for, to make sure that I have enough material. Now, one of the things I want to do, just to try to minimize the number of features that I'm going to have involved, is I'm going to do a 2-direction extrusion, and I want to try to use the draft feature as part of this. So let's go ahead and do this. Now, something that I mentioned as part of the introduction of this coursework is that a typical angle that would need to be used, draft angle that would need to be used for casting or forging, would be 3 to 8 degrees. And so I want to use 5 degrees on this, and we'll see what kind of results that we get as doing our extrusion as part of our draft as part of our extrusion. I don't want to have to do a mirror on this, and so I want to go ahead and use the direction 2, and I want to use that same offset from surface command. This time I'm going to use the offset from the back side, reverse offset at 30 thousandths of an inch. Notice how it automatically picked up the 5 degrees of draft. It assumed that if we were extruding with draft on direction 1, that we would also want to extrude with draft on the other side. Now there are times where, just for convenience factor, let's put that value back in. There are times for convenience factor that I will design something with the sketch in the middle of the part, but I want all the draft to continue in one direction. And so if that's the case, I could use the draft outward option, which would now continue that same 5 degrees of draft all the way to in one direction. And that would allow me to have a single direction pull on my mold. Well, in this case, we want that parting line right in the middle of the part, right where I sketched, and so we don't want to use the draft outward option. So I can deselect that, and as I use Control 4 to get to a front view, we can see that the expected taper at 5 degrees, how it's going to move away from the part. Now, because we dimensioned our sketch in the middle of the part, we don't know exactly yet what the outside dimensions are going to be at the furthest extremities of the part. So let's hit that green check mark and take a look at what we've got. Control 7 gets me to an isometric view.